Yes.
Yes, sir.
What we have done in the previous lecture?
Sir, we started that Laplace transform and we had seen some numericals.
Okay. So properties we have done. Properties, which means the theorems we have done. So theorems like Laplace of e to the power minus at f of t. This becomes capital F of s plus a, which means that f of s is replaced by s plus a. Okay. So only one lecture is done on Laplace transform, uh, in which we have found out the properties of Laplace transform, starting from the first one, Laplace of 1 and Laplace of these. So now I will just recall all the properties. So Laplace of f of t plus minus g of t. So Laplace transform separates over addition and subtraction. So this becomes Laplace of f of t plus minus Laplace of g of t. So this is capital F of s plus minus capital G of s. Then Laplace of k times f of t is equal to k times Laplace of f of t. So which means that k times capital F of s. Basic definition for the Laplace transform: integral 0 to infinity e to the power minus st f of t dt. So when you solve this integral, we get the Laplace transform of the function f of t, and it is denoted by capital F of s, which can also be written as Laplace of the function f of t. So this is equal to Laplace of f of t. So using this, we have found out that Laplace of 1 is equal to 1 by s. Laplace of e to the power at, that is equal to 1 upon s
1 by
minus a, 1 upon s minus a. Later, Laplace of sine of at is equal to a upon s square plus a square. Laplace of cos of at is equal to s upon s square plus a square. If cos and sine are hyperbolic, Laplace of sine h of at, then this is equal to a upon s square minus a square. Laplace of cos h of at is equal to s upon s square minus a square. Then Laplace of t raised to n is equal to gamma of n plus 1 upon s raised to n plus 1. These are the basic formulas, but depending on this, uh, we have derived some more, in which, I mean, those are the theorems which we will use directly in the examples. I think 1 and 2 we have already given in it. So I'll write down the theorems too over here. Theorems. First one, so I'll consider if Laplace of the function f of t is equal to capital F of s, then the first one, Laplace of e to the power at minus at f of t is equal to, you take the Laplace of f of t. Whatever answer you will get, in that what you have to do is you have to replace s by s plus a. Okay. First and a very important theorem, if you have e to the power at into f of t, what you do is you take out e to the power at, take the Laplace of the remaining part, and whatever answer you will get, in that you replace this s by s plus a. Then the second property or the second theorem, which says that Laplace of f of at is equal to 1 upon a capital F of s by a, right? So if I want to take the Laplace of the function f of at, which will mean that you take the Laplace transform of the original function f of t, okay, and in that you replace s by a. So I will write it down in an explicit form, 1 upon a f of s, in that you replace s by a. Third one, Laplace of f dash of t. This is equal to s into Laplace of f of t minus f of 0. So we have discussed that Laplace of f dash of t can be written as s into Laplace of f of t, the original function, minus f of 0. Look, even the formula is for just the first derivative. This can, of course, be generalized to Laplace of second derivative, f double dash of t. So what I can do in this is, I can take Laplace of f dash of t, uska derivative. So by this formula, we'll have s times Laplace of f dash of t minus f dash of 0. Then I will take the formula for Laplace of f dash of t. So that will be s into Laplace of f of t minus f of 0 minus f dash of 0. We can open the bracket, and what do we get? S square Laplace of f of t minus s times f of 0 minus f dash of 0. Okay. So Laplace of f double dash of t, I can find out similar way. I can find out the Laplace of third derivative. Okay. So remembering Laplace of second derivative, third derivative, those are difficult. So what we will do is we will just remember this formula. First one, s into Laplace of f of t minus f of 0. And wherever required, the Laplace of second derivative, third derivative, what we will do is we will find out using the formulas. Fourth one, Laplace of t into f of t. This is equal to minus 1 into d by ds of capital F of s. So if there are more t's, like Laplace of say t square f of t, then what we will do is just like the previous one, t into t f of t. And so what you will get is minus 1 square d2 by ds square capital F of s. Okay, though t square is there, then you take the derivative two times. If there is Laplace of t cube f of t, then what we will do is minus 1 raised to 3 d cube by ds cube capital F of s. So whatever number of times t is multiplied, that many times you have to take the derivative. Fine. Fifth one, Laplace of integral 0 to t f of t f of u du. So Laplace of f of u du is equal to 1 upon s 1 upon s capital F of s. What is capital F of s? The Laplace of the integrand 1 upon s Laplace of f of t. So if there is an integration, what do we do is for an integration we divide by s और integration के अंदर जो है उसका Laplace transform लेना है. Sixth and the last one, Laplace of f of t divided by t. So in this case, integral s to infinity Laplace of f of t ds. So looking at 3, 4, 5, 6, is there any conclusion that you can make? Do you observe anything from 3, 4, 5, and 6? Nothing. So derivative derivative is related to multiplication, and if there is an integration, then it is related to division. So if you see that there is a derivative, then there other side it will be multiplication. If there is an integration, then the other side you will have the division. So look at the third one. On the left hand side there is derivative, so on the right hand side there is multiplication by s. If on the left hand side there is multiplication by t, then on the right hand side there is derivative. In the fifth one you can observe that on the left hand side there is integration, on the right hand side there is division by s. The sixth one there is division on the left hand side, so on the right hand side there is integration. So integration is related to division and multiplication is related to the derivative. That is how you can simply remember 3, 4, 5, and 6. Whole of the chapter depends on these formulas. So memorize it properly. Wherever required, you should be able to use the formulas properly. For that, you will have to understand the notation capital F of S, capital F of S plus A, and so on. So right now, just take the screenshot of these all the formulas together so that I can go ahead and solve the examples. Then next. Yes. Example. Find the Laplace transform. Find the Laplace transform of the following. First one, I think this one is done. E to the power minus 3t, t raised to minus 1 by 2. This is done. Second, t cos 80. T cos 80. So the Laplace of t cos 80, you have written the formula somewhere. So on the left hand side there is t into cos of 80. So multiplication is there. So if on the left hand side there is multiplication, on the right hand side there is derivative Laplace of cos of 80. So we know that the Laplace transform of cos of 80 by the formula is what we have is s upon s square plus a square d by ds. So minus 1 Laplace of s upon s square plus a square. So derivatives with respect to x. So you will have to apply u by v rule. So denominator as it is, derivative of s with respect to s is 1 minus s as it is, derivative of denominator is 2s upon s square plus a square whole square. So this is equal to s square plus a square minus 2s square. So that will be a square minus a square with minus sign will be s square minus a square upon s square plus a square whole square. I hope it is clear. Have any doubt? Please ask. Next, 1 minus cos t divided by t. So Laplace of 1 minus cos t divided by t is equal to, so 1 by t on the left hand side On the right hand side, it will become integration s to infinity Laplace of 1 minus cos t ds. So s to infinity Laplace separates over addition and subtraction. So Laplace of 1 minus Laplace of cos of t ds. So Laplace of 1 is 1 by s minus Laplace of cos of t is s upon s square plus 1 ds. So integration 2 separates over addition and subtraction. So this will be integration s to infinity 1 upon s ds minus integration s to infinity s upon s square plus 1 ds. So derivative of s square plus 1 is 2s. So I will make the adjustment, multiply and divide by 2 in order to adjust the derivative of denominator in numerator. I have multiplied and divided by 2. Now we can integrate this. So integrating, so we'll have log s minus 1 by 2 log of s square plus 1 limits from s to infinity. Now if you put the upper limit, you won't get an answer. Okay. So at infinity, log of infinity will become infinity. So in order to make that integration valid, what we do is we adjust the terms in such a way that at infinity I should get an answer. So what we will do here is log a minus log b. We know that the formula is log of s upon under root s square plus 1 in s to infinity. When you put the upper limit, again the value does not exist, but in this key thing, what I can do is I can take s square common from denominator. So we'll have s upon s under root 1 plus 1 by s square. Now this 2 will get cancelled out, and now you have the limits from s to infinity. Now if you put infinity 1 upon infinity, this term will become 0, this one. So 1 plus 0 is 1. Log of 1 finally will become 0 minus log of 1 upon under root 1 plus 1 by s square. So which I can simplify and write it down as the same thing that we started with, s upon under root 1 plus s square. Do the cross multiplication, take s square outside, which will go in the numerator, and the answer is plus log of root 1 plus s square divided by s. Any problem, please ask.
Sir, I didn't get it, sir.
Now, which step you didn't get it?
Sir, from the integration part only. Starting, we took the first one
Hmm.
on the right hand side, second step.
On the right hand side, second step, integration of 1 by s and this.
Yes, sir.
You know the Laplace of cos of 80, that's what we have written, right? And then
Yeah,
integration is separated, 1 upon s ds. We know that integration of 1 upon x is log x. है ना?
log it. Yeah.
One more formula is there, The formula says that integration f dash of x upon f of x dx. मतलब अगर डिनोमिनेटर का डेरिवेटिव ऊपर है, इन दैट केस आई कैन डायरेक्टली राइट डाउन द आंसर एज log of f of x like denominator. So in this case s square plus 1 है, तो इसका डेरिवेटिव आई नो दैट इट इज 2s. So I have to make 2s in the numerator. So to making in order to make 2s, what I have done is I have multiplied and divided by 2 there. So s square plus 1 का डेरिवेटिव आ गया ऊपर. So by this formula, the answer will be equal to log of s square plus 1. Is it right here?
Yes, sir.
Huh. Now, if you put infinity, log of infinity becomes infinity. I mean, you won't get an answer. So that's why what I have done is I have simplified it to this form. So log a minus log b. So that will be log of a by b, s upon under root s square plus 1. Now, I have took s common from the denominator. So what I have got 1 plus 1 by s square, under root के बाहर s square s हो जाएगा, which will get cancelled out. Now you can put infinity and you can get the answer 0. And the further is just the simplification. Is it clear now?
Yes, sir.
Okay. Next example, fourth one, t e to the power 3t sine of 2t. So we need to find Laplace of t e to the power 3t sine of 2t. So we'll break this into parts. So first of all, I can always remove e to the power 3t. So what I'm saying is we will write it down in this pattern, e to the power 3t t sine 2t. Okay. By our first property, it says that I can remove e to the power 3t and I can take Laplace of t sine 2t, but at the end I will have to replace s by s minus 3. Okay. So we need to find out Laplace of t sine 2t, whatever answer I will get. So in that I will replace s by s minus 3. So now Laplace of t into sine 2t, we have seen that multiplication is related to the derivative. So t into sine 2t, so minus 1 d by ds, and I have to take the Laplace of sine of 2t. S will be replaced by s minus 3. Now minus 1 d by ds, we know that Laplace of sine of 2t is 2 upon s square plus 2 square. Then s replaced by s minus 3. Now this is equal to minus 1 d by ds. Oh, sorry, let's take the derivative now. So derivative of 2 upon s square plus 4. 2 is a constant. 1 upon, it is simply like the taking the derivative of 1 upon x. So that will be minus 2 upon s square plus 4 whole square. By chain rule, derivative of s square plus 4 is 2s. And at the end, replace s by s minus 3. Now minus sign will get cancelled out. What do we have is 4s upon s square plus 4 whole square, replace s by s minus 3. So the answer is 4 into s minus 3 upon, in bracket, s minus 3 square plus 4 whole square. And so we can simplify this. So 4 into s minus 3 upon s square minus 6s plus 9 plus 4, which is 13 whole square. So final answer.
Sir, what if we simplify it before replacing s?
Before replacing s, you are taking square over here, s square plus 4.
Yeah.
Okay, no problem. Next example, the fifth one, Laplace of, we will have to try this. The function is integration 0 to t sine of t by t dt. Try this. Okay, so Laplace of 0 to t sine of t by t dt. So since we have integration, what we have to do is 1 upon s and take the Laplace of the thing which is inside the integral, sine t by t. Then 1 by s. Then there is division. So I will have to integrate s to infinity Laplace of sine t ds. So this is 1 upon s integral s to infinity Laplace of sine t is 1 upon s square plus 1 ds. Now 1 by s, integration of 1 upon s square plus 1 is tan inverse s, limits from s to infinity. So this is 1 by s in bracket, tan inverse of infinity is pi by 2 minus tan inverse of s. So pi by 2 minus tan inverse of s is 1 by s cot inverse of s. This is our final solution. It's easy. I mean, it's not at all difficult. You just have to go on using the formulas again and again. That's it. Next example, t integration 0 to t e to the power minus 4t sine of 3t dt. So we need to take the Laplace of t integral 0 to t e to the power minus 4t sine of 3t dt. So there is t into this thing, the integration and whatever. So since there is a multiplication, minus 1, take the derivative, whatever is inside it. Laplace of integral 0 to t e to the power minus 4t sine of 3t dt. Now minus d by ds. Now since there is an integration, so what we will have to do is 1 by s, and Laplace of whatever is inside the integral e to the power minus 4t sine of 3t. Now e to the power minus 4t into f of t is there. So we'll use the first formula. By the first formula, what we will have, d by ds in bracket 1 by s curly bracket Laplace of sine of 3t. Whatever answer turns out, replace s by s plus 4. Uh, I hope it is clear up to this. I will go ahead 1 upon minus d by ds 1 upon s. Laplace of sine of 3t is 3 upon s square plus 9. I have to replace s by s plus 4, bracket complete. So this is minus d by ds in bracket 3 upon s in bracket s plus 4 whole square plus 9. So I can simplify this, minus d by ds in bracket 3 upon s in bracket s square plus 8s 6 plus 25. So this will be equal to minus d by ds in bracket 3 upon s cube plus 8s square plus 25s. So we can take the derivative. It is the derivative of the form 1 upon x. Okay, and you apply the chain rule. So what it will turn out to be 3 upon s cube plus 8s square plus 25s bracket complete square by chain rule derivative of this term. So that will be 3s square 16s plus 25. This is the final solution. If you have any problem, you can ask. Clear? Yes?
Yes, sir.
Yes. So there is this last type of example which are very important, which says that evaluate the integral using Laplace transform. Evaluate the integrals using Laplace transform. First one, integral 0 to infinity t e to the power minus 3t sine t dt. So what we are going to do here is, I'll just recall what is the basic definition. So first of all, I will write this integration as 0 to infinity e to the power minus 3t in bracket t sin t dt. We have a basic definition. Laplace of f of t is given by integral 0 to infinity e to the power minus st f of t dt. This definition we have seen in the first lecture. So when I want to find Laplace of f of t, the answer is given by 0 to infinity e to the power minus st f of t dt. Right? Now, I will write down Laplace of t sin t. What this will be equal to? Integral 0 to infinity e to the power minus st t sin t dt. Can you compare this to and tell me how can I find out the integration? Can you compare the two things?
Sir, it's the same
No, it's not the
almost.
same. There is some difference. Looks almost same.
T T is multiplied just.
T is multiplied. No, T is multiplication on both the sides. I mean, here too you have T times sin T. If you see on this side, the right hand side, if you put s is equal to 3, so for s is equal to 3, you can see that the integration you will get. I mean, the you can get this integration by putting s is equal to 3. So what I can do is I can find out this Laplace transform of t sin t, and in that what I'm going to do is I will put s is equal to 3. Okay, so how to put this? So we know that Laplace of t sin t is equal to integral 0 to infinity e to the power minus st t sin t dt. For s is equal to 3, we get required integral. Required integral. So what do we do? So we have Laplace of t sin t. There is multiplication, so derivative on the right hand side minus 1 d by ds. Laplace of sin t. Laplace of sin t is 1 upon s square plus 1. So this is minus 1 into derivative of 1 upon s square plus 1 is minus 1 upon s square plus 1 whole square by chain rule 2s. So this is equal to 2s upon s square plus 1 whole square. So from all this, collecting everything together, what I can write it down is integral e to the power minus st. So so we get integral 0 to infinity e to the power minus st t sin t dt is equal to 2s upon s square plus 1 whole square. So put s is equal to 3. So what we got? 0 to infinity e to the power minus 3t t sin t dt. So the answer is 6 upon 9 plus 1 10 10 square 100. Sorry, 3 by 50 is our final answer. Clear with this? Now, one example for you. Second one, integral 0 to infinity e to the power minus t sin t by t dt. Let's see who can find out. I'm not going to solve it. I'll give you the final answer in case no one is able to solve.
Sir,
Yes,
is the answer minus 1 by 45?
minus 1 by 45. No, the answer is pi by 4. Okay, you try it later. So right now we will stop. Our Laplace is over. We'll start with inverse Laplace transform tomorrow. So I'm considering that you are able to solve all the Laplace transform, whatever type of examples I have covered. You have understood everything. Fine. Thank you, everyone.